Hello, Mrs. Butra here. This video is on slope, graphing, writing equations, slope-intercept form, standard form, and point slope form. In other words, line stuff. Okay, we're going to start with some definitions. The first one we have to do is slope. You guys should know what slope is by now. It's the rate of change, so that's an important thing to remember, rate of change. It's the rate of change of the dependent quantity, so whatever your y value is, in relation to the independent quantity. So if I was to ask you what slope represented in the real world, you would want to say it's the rate of change of, and maybe if we were doing something like speed, that's something you guys can relate to, it'd be the rate of change of the miles in relation to the hours driven, miles per hour. So your equation, the slope formula, to find the slope, m is what we use to represent slope. M is equal to y2 minus y1, the change in y's, divided by x2 minus x1, the change in x's. So x2, y2 would be a point, and x1, y1 would be a point on the line. And I know you guys know this, but the slope-intercept form of a line is y equals mx plus b. M is your slope, b is your y-intercept. Standard form of a line is in the form ax plus by equals c, where a, b, and c are always integers. A, b, and c are always integers, not fractions or decimals. The a comes first, the ax part comes first, the by part comes second, and then the equals, and then the constant. And a is positive. So if you come up with a negative a, you just need to switch the signs on all of them, and then a will be positive. And then the form that you might not be as familiar with, but I want you to get more familiar with it this year, is point slope form. It's actually the easiest to do, because if I give you a point and I give you a slope, you could draw that picture on the graph and figure out your y-intercept and then write it that way. Or you can just put it in point slope form immediately, y being the variable minus y1 being the y value of your point equals m your slope, x being the variable x, minus x1, the x-coordinate of your point. And that's it. All right, the next thing we're going to talk about is classifying our lines by slope. The slope of a line will tell you if that line rises or falls, and we always go from left to right, so rises or falls, or is horizontal or vertical. If you've got a positive slope, it's going up. Positive, you're climbing up. If it has a negative slope, you're sliding down. Zero slope is horizontal. So if you think about it, you have zero rise over all run. So if you think about this, 0 divided by anything equals 0, right? That's your slope. And if I don't rise any, but I run completely, then I'm going horizontal. Now, on a vertical line, I have I have all rise, and I have 0 run. But you can't divide by 0. You can never divide by 0, so that's why we call that one undefined versus that one being 0. So undefined. So you can think of it in terms of your slope, and the slope being a fraction. If the 0 is on top, horizontal line, 0 slope. If the 0 is on the bottom, it's a vertical line, it's undefined slope. This next little bit is about slopes of parallel and perpendicular lines. And you guys have learned this before as well, but just to remind you, parallel lines have the same slope. If they're parallel, they're going in the same direction, same rise, same run. Perpendicular lines have negative reciprocal slopes. You have to remember to take the opposite sign. So if it was already negative and then you negate a negative, negative times a negative is positive, and then reciprocal, flip the fraction over. So here's a quick example. I might say, write the equation of a line that passes through 8, negative 1, and has a slope of negative 1/2. So if I give you a point and the slope, you should think, okay, then I'm going to use point slope. So we're going to say y minus, and then y1 is this number. So y minus negative 1 becomes y plus 1 equals, and then your slope, so negative 1/2, and then x minus, and here's x1. And so that's point slope form. You don't have to convert it to slope-intercept form unless the instructions tell you to. So if it just says write an equation, that is an equation, you're good to go. Just plug the point in, the point being 8, negative 1, and plug the slope in, negative 1/2. And that's it. Another example you might be given would say something like, write an equation of the line that passes through negative 2, 1, so there's a point, and is perpendicular to the line y equals negative 3x plus 1. So if you're asked for something that's parallel or perpendicular to another line, that other line is given to you only so that you can take away its slope. That y-intercept is not going to have anything to do with your line, just the slope. So we know that perpendicular lines have negative reciprocal slopes. So my slope, the opposite sign of negative is positive, and the reciprocal of 3 is 1/3. So that's my slope. This is my point, x1, y1, and then I'm going to do exactly what I did up above. I'm going to say y minus y1 equals m, and then x minus, and then x1 was negative 2, so x plus 2. And if the instructions tell you, now put it in slope-intercept form, then all you have to do is distribute your 1/3 and then add 1 to the other side. For this next example, yes, I've cut and pasted. I didn't really feel like typing it all out. You're going to have to write it if you want this in your notes. It says, in a chemistry experiment, you record the temperature of a compound to be negative 5 degrees Fahrenheit 1 minute after you begin the experiment. 5 minutes later, the temperature is 20 degrees Fahrenheit. Write a linear equation that models the temperature of the compound in relation to elapsed time. So first we have to figure out, okay, what is independent and what is dependent? We know that the time doesn't depend on the temperature, and it's the other way around. The temperature of this experiment depends on the time. So x is going to be time, and y is going to be temperature. So then we look and we pull out ordered pairs from our problem. We say, all right, the first ordered pair that we have is the time is 1 minute, and the temperature is negative 5. The other ordered pair, there's always going to be 2 if I'm trying to do a line, or they'll give you a slope, but 5 minutes later. So 5 minutes later means that next point is at 6, right? And then the temperature is 20, so 6:20. Those are the 2 points that we're going to work with. When you have 2 points, to write the equation of the line, you're going to need a slope. So to find the slope, we use the slope equation, y2 minus y1 over x2 minus x1. And we get 25 over 5, which gives us a slope of 5. So we're going to use this 5, and then you can use either one of the other points. It doesn't matter. I'm going to go with 620 just because there's no negatives. So I'm going to say y minus y1 equals m, x minus x1. And maybe I want it in slope-intercept form. Then I would just distribute the 5x minus 30, and add the 20 to the other side. So I get y equals 5x minus 10. So now what is the slope even in this problem? I'm probably going to ask you that a bunch of times because it's very important to understand what the slope even represents. And in this problem, we just say it's the rate of change of and then temperatures on top and times on bottom. So it's the change of temperature in relation to time. More specifically, that slope of 5 means it changes our experiment. Here, I'm going to write it on the next page. But the experiment changes 5 degrees per 1 minute. All right, so your slope is the change of 5 degrees per 1 minute elapsed. What if I asked you, what is the y-intercept? What does that negative 10 even represent? Well, that's negative 10 is what happens when x is 0. So it's saying at time 0, when the experiment began, the temperature was negative 10. So that negative 10 represents the temperature at the beginning of the experiment. There. Sorry, not very pretty, but you've got it. You've got the information now. All right, our final example, we're going to graph negative 2x minus 3y equals 6. This is in standard form, so you could convert it to slope-intercept form and graph it that way, but I would like to show you how we graph something straight from standard form. All you have to do is figure out what your intercepts are. When you plug a 0 in for x, just cover up the 2x with your finger. Let's see, I think I have a little. Anyway, like cover that up, and then you have negative 3y equals 6. So if you divided 6 by negative 3, you'd get a y value of negative 2. So 0, negative 2 is your y-intercept. See? And then to find your x-intercept, you plug a 0 in for y. So if you were to cover up the minus 3y, because that equals 0, then negative 2x equals 6, you're going to get x equals negative 3. So you have a point at negative 3, 0. That's your x-intercept. And then once you have 2 points, you don't need anything else. You just connect the dots. So it's easy if you just find the intercepts. And that is all I have for you guys tonight. So have a great weekend if you haven't already had a great weekend. And I'll see you in class on Monday.